Here is our video for reciprocal functions, reciprocal trig functions. And I want to start by just reviewing what we mean by a reciprocal. For example, if I gave you the number 3/4 and asked you for the reciprocal, you would flip this around and make it 4/3. Or if I asked you for the reciprocal of a natural number 2, you would put it over 1 first, then flip it, and it would become 1/2. So that's what we mean by a reciprocal of a number. But we've been working with trig functions, and you can also take reciprocals of them. So let's say I wanted to take the reciprocal of cosine of some angle theta. Just like over here when I had 2 and I put it over 1, I'm going to do that here. And then the reciprocal is 1 over cosine theta. And we can take the reciprocal of all of our trig functions that we've talked about so far: cosine, sine, and tangent. And these are very useful and very common, and so they get their own name. The inverse of cosine is called secant. We use SEC for the shortcut. So 1 over cosine, the reciprocal function for cosine is called secant. So down here we have the 3 standard forms. Reciprocal of cosine is called secant. The reciprocal of sine is cosecant. And the reciprocal of tangent is cotangent. And just remember, we talked the other day about how tangent is sine over cosine, so it makes sense that the reciprocal of it is cosine over sine, or also you can just think of it as 1 over tangent. And so all we're going to do is practice a few of these problems together. I'll do a few, I'll ask you to pause the video and try a few, and then the remaining ones you can do on your own and check it with the PDF in your Google Classroom. So looking at number 1 here, we're being asked to find the cotangent of 30 degrees. So what that means is 1 over tangent of 30. And I'm going to show you a few ways that you can work with the tangent problems. So this way is just saying it's 1 over tangent of 30. And then I go to my unit circle and find 30 degrees. And the tangent of it is rad 3 over 3. So I will plug that in. So now I have 1 divided by a fraction, and we talked the other day about when you're dividing by a fraction, it's the same as multiplying by the reciprocal, or keep, change, flip, meaning you keep the numerator the same, so it stays 1, change, divide to multiply, and then take the reciprocal of the bottom number. So rad 3 over 3 becomes 3 over rad 3. And now when we multiply fractions, we multiply across the top and the bottom. 1 is really over 1, so I could multiply here. One thing I'm going to fix right now, though, is rationalize this denominator. I don't want a radical in the bottom, so I'm going to multiply by rad 3 over itself. Now when I multiply across my numerators, I have 3 rad 3, and across my denominators I have rad 9, and the square root of 9 is 3. So the radicals cancel each other out. And now I have one more thing I can do. These 3's are both outside of radicals, so they go together, so to speak, and I can simplify that fraction. 3 divided by 3 is 1, and now my final answer is just radical 3. A second way we could have done this problem is I could have said that if I already know that this is the reciprocal of the tangent of 30, then once I found on my unit circle, once I found the tangent was rad 3 over 3, I could just immediately take the reciprocal of it and start there. So I would have just started here as my first step, 3 over rad 3, and then rationalize the denominator, and then simplified the 3's. And the third way that I want to bring to your attention is that I could have used this ratio right here. Cotangent is cosine over sine of the angle. So that would have been cosine 30 over sine 30. Remember, cosine is the x coordinate of the ordered pair at 30 degrees. So that's rad 3 over 2. Sine 30 is the y coordinate of the ordered pair at 30 degrees. That's 1/2. So this is, again, multiplied by the reciprocal situation. So the top number stays the same, rad 3 over 2. Change division to multiply, flip the bottom fraction. Now we're multiplying across the top and bottom. Anytime you have the same thing on top and bottom, they cancel, leaving me just rad 3. Okay, so you have 3 options when you're dealing with cotangent. So now I want you to pause your video and try number 2, secant of pi over 3, by yourself. Okay, so secant of pi over 3 is 1 over cosine pi 3. And cosine at pi over 3 is the x coordinate there, so this, and it's 1/2, so 1 over 1/2. So multiplying by the reciprocal, 1 times 2 over 1, and that is just 2. And you don't have, again, you don't have to go through the trouble of writing out this every time. You could have just found the x coordinate of pi over 3 on your unit circle, 1/2, and you know you're taking the inverse of it, 2 over 1. And it could just be that simple. I just like to give this extra detail for anybody who visually wants to see what's happening. So pause the video and do 3, 4, and 5 on your own. Okay, for number 3, cosecant is the inverse sine function. So we are going to take the inverse of the y coordinate at 120. So sine means the y value. So I go look at 120. The y coordinate there is rad 3 over 2. I'm going to take the reciprocal of that. So I'm going to flip it, 2 over rad 3. We don't want to stop there because we want to rationalize the denominator. Multiply across the top and the bottom. See if you can simplify 2 over 3. You can't, so you are done. Cotangent of 0 degrees. I'm going to use my unit circle. I'm going to find 0 degrees right here. The tangent is 0, so I'm going to take the reciprocal of 0. Well, just like when I took the reciprocal of 2 here, remember I didn't originally have that 1. I wrote it over 1 and then took the reciprocal. So I'm going to do that here as well. 0 over 1. The reciprocal is 1 over 0, and now we have an undefined situation because you cannot divide by 0. For cosecant of pi over 2, it's the reciprocal of sine pi over 2. That's the y value there. So the y value at pi over 2 is 1, and the reciprocal of it is 1 over 1, or just 1. I'm not going to work 6, 7, 8, 9. You can try those on your own. Find the answers in your Google Classroom. Now I want to talk about 10, 11, and 12. It's a different setup. So 6, 7, 8, 9 is just more practice with what we've already done here. The difference on 10 is I've got an equation. This is asking me the cotangent of what angle equals radical 3. the cotangent of what angle equals radical 3. So we don't have the trig functions on here, so I can't just read off cotangent from here. So what I'm going to do is set this up. I'm going to say, well, this means 1 over tan. And in order to solve for x, it would be really helpful for me if it wasn't in the denominator, if this function was in the numerator. So it'd be really helpful for me if these were flipped. And because this is an equation, I can preserve the equality and the proportion from left to right if I also flip the right-hand side. I know that this is rad 3 over 1. So if I want to flip the left side, I can flip the right side. And so now I have this. Tangent of x equals 1 over rad 3. So now I'm being asked the tangent of what angles is equal to 1 over rad 3. Now remember, none of our angle or none of our tangents are going to be in this form because of the radical in the denominator. So let me change this form by rationalizing it. And this is going to now give me tangent of what angle equals rad 3 over 3. So I want you to pause your video and go find the 2 places on your unit circle where the tangent is rad 3 over 3. All right, so hopefully you found the 2 places to be 30 degrees and 210 degrees. Now the directions didn't ask for degrees or radians, so I'm just going to put both answers here. 30 degrees is pi over 6 and 210 degrees is 7 pi over 6. Now I want you to pause the video and try 11 by yourself. Okay, so I'm going to work 11 the same way. Secant is 1 over cosine. I want to get this x up in the numerator to help me solve. So I'm going to flip both sides of my equation. Those are double arrows, by the way. I don't know. Came out looking weird. So cosine x equals negative 3 over 2 rad 3. Again, can't have the radical in the denominator, so I'm going to rationalize it. Multiplying across the top gives me 3 rad 3. Now on the bottom I have 2 times 3, because rad 3 times 3 is 3. Notice I now have a 3 in the numerator and denominator. Those simplify to 1. So now I have negative rad 3 over 2. So the cosine of what angles equals negative rad 3 over 2. Remember, cosine is your x coordinate. So look where on your unit circle where you can find x coordinates of negative rad 3 over 2. So pause and check that out. And hopefully you found that to be 150 degrees and 210 degrees. And in radians, 150 is pi over 6, and 210 is 7 pi over 6. And then try 12 on your own, and you can find that answer in your Google Classroom PDF.